Welcome to this short presentation regarding empirical methods. I would like to start with an hypothesis, and I search data for this hypothesis. Suppose I think that institutions measured through property rights are related to GDP per capita. And suppose also that I think that better institutions lead to a higher GDP per capita. Okay? So what may I do and how may I start? Well, I may try to collect data, which I have already here. I'm looking at institutions in the United States, high institutions, and also high GDP per capita. I have Germany here, China, medium institutions, medium GDP per capita, and I may put Uganda here as an example. Plus, I'm collecting data from other countries around the world. What you can see already here, if I make a scatter plot like that, most likely you would put through a line like this one. So there's a positive correlation between these two variables, giving me an indication that, well, they are correlated, that maybe there is also some causal mechanism going on. In fact, what I'm doing here is just that I'm estimating a linear relationship. Okay, this is a linear curve. What do I have? I would say that ln GDP per capita is explained by alpha, a constant, plus beta 1 times property rights. So property rights may have an effect on ln GDP per capita. I can estimate this linear curve here. Okay, the alpha would be this one. That's the starting point of the curve. If we have 0 here, okay, and the beta 1 is simply the slope of the curve, nothing more. Okay, suppose the beta 1 is 0.98. Okay, a positive coefficient of 0.98, and say the alpha equals, well, say 2.4. Okay, that's what I get from the estimate if I'm running it through the computer. So then this would be the best fit of the line, showing this simple relationship here. Thus, I could write in this setting that ln GDP per capita equals 2.4 plus 0.98 times PR. Thus, for every unit increase in property rights, okay, I'm getting a log GDP that is 0.98 log points higher. So I'm having this positive, let me call it for the moment, effect of higher property rights on GDP per capita. One additional property right, 1 point in the property rights scale, gives me 0.98 log points regarding GDP, which would be quite a lot. Okay, so fine, there's nothing magic to it. Okay, what can I do next? I can draw the graph again, okay? And maybe the reality doesn't look as smooth as I have it out there, but rather that the dots are a bit more widely distributed, okay? So if you look at that, I can put through this line, but in principle, so this is one line with the 0.98, but it could also be that actually the true relationship is somewhat steeper. So this one, okay? Say this is 1.2, okay? It could also be that it's rather 0.81, okay? So I'm making an error in my prediction. So the error is reflected by the distance to the different dots that I have. Okay? I'm making prediction errors when I'm claiming that the true relationship is 0.98. I can take account of this prediction error, which would be, I'm trying to estimate then a standard error. So the error that I'm making can be translated to a standard error. Okay, standard error. If the standard error is very high, then that means that my prediction is not So good. If the standard error is comparatively low, then my prediction is better. Suppose I'm having a standard error here for this curve of, say, 0.21. Okay? Usually I represent the standard error in parentheses together with the coefficient. I'm also having a standard error for the alpha, so for the constant, say it's 1.2. Okay? If the standard error is low in comparison to the coefficient, then I'm having a relatively precisely estimated relationship. Now, what is high and what is low? Huh? Well, that depends on choices. Usually we say if the standard error, is 1.65 times lower than the coefficient, then we are having a 10% confidence interval. Okay? If the standard error is 1.96 times lower than coefficient, then we are having a 5% standard error. What does the standard error together with the coefficient represent again? I'm drawing it here. Here is 0. Say I'm having here 0.98. So if the standard error is rather high in comparison to the coefficient, it means that I have a good probability that the true coefficient could also be 0. Okay? Versus if the standard error is comparatively small, then I'm getting also a relatively precisely estimated curve. I'm getting a relatively precisely estimated coefficient, and that's what I usually want. Thank you very much for your attention.